All right, it's time for our last lecture video of Chapter 7. This is the following table shows the median age at which men and women first get married in the U.S. Let M of t and W of t be functions for the median age at first marriage for men and women in the U.S. respectively at t years since 1900. All right, so here's our men, here's the women, and so on. And then here are the two scatter plots. So there's the median age at first marriage for men. Here's the median age at first marriage for women. And these are the various years. So judging from the scattergrams for each of these data sets, would it be best to use a linear, exponential, or quadratic functions to model these data? Well, rather obviously quadratic, right? For one thing, we're in the section that talks about quadratics, but for another thing, because both data sets have points that go down and then back up, forming kind of a U shape, right? The classic parabola shape. It's a pretty shallow parabola. It's not very steep, but nevertheless, it's forming that go down, back up. And the only way we know how to deal with that is with a quadratic model. All right, so now we're going to find quadratic models for both of those using regression and find the r-squared value for each one, and what does that indicate? Okay, so let's grab a calculator. Stat, edit, clear out the old, and type in the new. So if I'm not mistaken, it goes 40, 50, 60. Yeah, because it's since 1900. So 40, 50, 60. Okay, and then we'll find them, put the men here. So there goes the men, and then here goes the women. All right, there they are. Boop. Boom. All right, so now let's find each regression equation. So we'll start with the easier one, which is the men, because they're in L1 and L2. So I'm going to hit number 5, quadratic regression. And then L1, that's my years. L2, that was the men. That's perfect. And I think I need this data. Let's see. Use the models. Yep, we're going to need these models. So I'm going to actually store it right now in Y1 for myself. So variables, Y variables, 1, 1. Enter. Then I calculate it. It runs it all for me. And then it has the equation stored. If you go to Y equals, you can see it. It's right there. Right there. And I don't want that Y2, so I'm going to clear that out. All right, so there's the men's data right there. So let me go back, quit, and oops, I lost it. Stat, calc, number 5. Fine, enter. There we go. Okay, so let me take a picture of that, because I'm going to type my regression equation from that. So let's see, for the men, M of t, it's equal to approximately 0.002 t squared minus 0.206 t plus 29.002. Oh, and r squared. R squared. Oh, it wanted 4 decimal places. Oops. Okay. So 182060. So that one's fine. And 29.00118, actually, because the 8 will round that 7 up. And then r squared was approximately 0.9342. All right, so there's the men typed in. And now I need the women. So we've done this before back in chapter 3, but it's been a while. So you hit stat, you hit calculate. You want number 5 again, because it's quadratic as well for the women. L1 is still your X list, it's still your years, but your data is in L3, so hit second 3, enter. Always leave the frequency list blank, and I'm going to store the regression equation, variables, Y variables, function, but instead of Y1, the male model is in Y1, so I want the female model to be in Y2. So I'm going to store it in Y2, calculate. I'll use that for later. And then just, if I hit Y equals, you can see there's the men for y1, there's the women value for y2. Okay, so let's go back here and type up what the women model was. So W of t is equal to 0.0019 t squared minus 0.2045 t, and then 26.125. There we go. And r squared was 0.9516. All right, so both models have a very high r squared value. Which supports the selection of quadratic models for both data sets. Right? All right, so now we're going to use those models to predict when the median age at first marriage will be the same by drawing a picture on our calculator. Okay, so let me just make some space in here somewhere. All right, I've given the window right here in the notes, so we're going to follow that window. 0 to 250, 20. 0 to 75, 15. All right, so let me press window. 0 to 250, and then 20, I think. 20. Let me go back. 0 to 75, 15. Okay, 0, 75, 15. And then I'm going to hit graph. So there's the male data, blue, and there's the female data, which is red, right there. And you can see they intersect right in there. See that? Where they're kind of on top of each other. All right, so we are going to, I bet, find that intersection. Use the models to predict when the age of first marriage will be the same. So we're finding the intersection. So let's grab that. Second calc, number 5. The blue curve is indeed my first curve, so enter. The red curve is indeed my second curve, so press enter. And then guess, I'm just going to kind of move my blinker cursor thingy-mabobber over here to the right. That's his official name, thingy-mabobber. And press enter. And there it finds it. Now I draw a sketch on my paper, which again is much easier for me than it is for you guys. Sorry about that. So you draw a quick sketch of it. And now we are going to have to explain what that means, right? Oh, actually, no. It just says use the models to predict when the age at first marriage was the same, so, or will be the same. So 198.5 is our x value. That's our time. When, because they say when. See that word right there? So they're asking for a time word. So we really only need the t value. So t is approximately 198 and change. 198.55. Okay, so what does that mean? What year would that be? Our starter year was 1900, right? So you take 1900 plus 198.55, and you get in about 2098. So in men and women will have the same age at first marriage in 2098 according to the model. Now it doesn't actually look very sensible, because if you look at this, it's saying sure they'll be the same and they'll both be getting married for the first time around the age of 60, which doesn't seem to be very practical, but nevertheless, that's what the model's appearing. So 2098 is actually the answer to the question that was being asked. So it appears that men and women will be married for the first time together in 2098 at the age of 60. That's when men's age at first marriage and women's age at first marriage will be the same. All right, last but not least is an optional bit, which is to do what we just did by hand. So let me set these two models equal to each other, because what we want to do is we want to know when is men and women equal to each other. When are men and women equal to each other? So I want this to be equal to this. So what I'm really asking you for here is when will the male be equal to the female? The men at first age at first marriage, I should say, be equal to the female age at first marriage. Okay, so what you do is you set the two equations equal to each other. And then you want to get it all on one side. So if I were you, see this 0.0019? That's larger. So subtract this whole left side, right? Bring this all over to the other side. So minus the 0.008 plus the 0.260 and minus the 29. That'll cause the entire left side to disappear. And then if you do it over there to the left-hand side, you have to do it over here to the right-hand side, which looks like a mess, but it's not too bad, because over on the left you're going to have 0 equals 0.0001 t squared, right? So I'm just subtracting. And then, let's see, because 19 take away 18 is 1. And then negative 0.2045 plus 0.2060. So negative 0.2045 plus 0.2060 is 0.0015. So plus 0.0015t, and then I need 26.125 take away 29.0018. So 26.125 take away 29.0018. Negative 2.8768. Oh, I already forgot what it was. All right, minus, what was it? 2.8768. There we go. And this is all equal to 0. Right? Oops, I had it equal to 0 over there. But 0 over here, 0 over there, doesn't matter. Hey, it's a quadratic. It's an ugly quadratic. So t is equal to negative b plus or minus square root b squared minus 4ac all over 2a. And you've got some pretty ugly decimals in there, so let me type those in. There we go. Ugh, it's pretty terrible, I know. But we're going to make the calculator find what this whole thing is, right? Because we don't need that by hand. So, I mean, we're trying to come up with decimals for all this anyway. So it's 0.0015 squared minus 4 times 0.0001, that was your A, times your C, which was negative 2.8768. All right, so all of that goes under the square root. So it's going to be, there we go. And then the denominator is just going to be 0.0002. All right, so this is two answers. I'm going to have to find them both. T is the negative one of this and the positive one of this. So let me go type those into a calculator. Let's see. I'm going to make this go away so we can see it. Okay, so we want negative parentheses, negative 0.0015 minus the square root of 0.00115297, close parentheses. I want to divide that all by 0.0002. Enter. So there's the negative one, and then I do second entry again, and all I have to do is change that one minus sign to a plus sign, and it's the same problem as before. Plus. Enter. So I get 162 and negative 177. Okay, so t is 162.27. We're going to scratch off the negative one because that doesn't make any sense. Now you might be thinking, well, that didn't really match what we did when we did it with the calculator. But that's because the calculator kept all the decimal places. If I reran it with the calculator with the models being rounded as they're supposed to be, then when I run the calculate intersect thing, it'll actually find the same value if I round all the models to the 4 decimal places as required by the problem. So according to the rounded models, men and women will have the same age at first marriage in 2062. But the unrounded ones with all decimals, it was more like 2098. But that's okay.